Hello, and thanks for using Tick Boom. We're told in this question that the complex numbers a equals 3 plus I, b equals negative 5i, and c is equal to 2 plus 2i are represented by points a, b, and c respectively. Find distances AB, AC, and the angle BAC, and hence the area of triangle ABC. And the student who sent this through indicated that they were okay with finding distances AB and AC, but they were struggling a little bit with finding the angle BAC. Alright, so to help, I've drawn up an argand plane here because we're going to, as the first step, plot our points and then see how we can deal with the resulting triangle. So we're told that there's a complex number a, which is equal to 3 plus I. There's a complex number b, which is equal to negative 5i. And a complex number c, which is equal to 2 plus 2i. And these will each be represented by the capital A, B, and C. So natural first step would be to plot each of these. So for A, we'd go 3 in the real plane and 1 in the imaginary plane. For B, we've got 0 in the real plane and negative 5 in the imaginary plane. So this is point A and this is point B. And then point C is 2 in the real plane, 2 in the imaginary plane. So that's point C. And so if I connect those, we get our triangle ABC. Now we're told in the question that eventually we want to find the area of the triangle ABC, so the area of this triangle. And we're going to do that by finding the length of AB and AC. And we're also going to find the angle BAC. So that kind of hints to us that the formula we're going to use for the area of the triangle, rather than the half times base times height, which is probably the one we're most familiar with, we're going to use the side angle side method for the area of a triangle. So that will tell us that the area of triangle ABC will be equal to the length of AB times the length of AC. So length of AB times the length of AC times the angle between them. So times the sine of the angle between them, BAC, all divided by 2. So that's what we're working towards. So we just need to find these ingredients. Now I think I think there's a few ways you could go about this. To me, the most straightforward way is to try and take what is, a complicated looking triangle and turn it into right-angled triangles, because with right-angled triangles, things get a lot simpler. And so if we can get each of these lines to relate to a right-angled triangle, then I think we could find this angle here that we need using the cosine rule. If we have all of the sides of the triangle, even though we're only told to think about 2, I think that's to hint to us this side angle side method. But actually I think if we find all 3 lengths, we can use the cosine rule to find this angle, and then we'll have all our ingredients to plug in for the area. So I think step 1, finding all these sides, I think I'll just use some different colours. Let's use red. So I think the first right-angled triangle that I think will help us is this one here. So if we've got ABC, I might just call this point D. So we've got a right angled triangle here. And maybe what I'll do is I'll just draw this up separately down here. So this won't be to scale, but I'll just keep the shape somewhat similar. So we've got this triangle A, B, D, which is right angled. Now, because of the way I've drawn this up in the grid, we can kind of just look to find the lengths of two of the sides. So this AD length has a length of 3 units. And this DB length has a length of 5 plus 1, so 6 units. So we can kind of use Pythagoras to say this length, AB, will be the square root of 6 squared plus 3 squared, which will be, and I'll just plug this into my calculator so I don't make mistakes, 6 squared plus 3 squared is 45. Alright, so we've got the length of AB, square root of 45. Now, I think for the length of, let's do AC, I think we can use this right angled triangle. So if I just replicate that down here, we'll get so we've got A, B, C, D. So I'll call this point here point E. So we've got A, C, E. And again, visually I can see that the length from A to E is just 1 unit, going from 2 to 3. So that's 1 unit. And the length from E to C is also 1 unit. So this length will be the square root of 1 squared plus 1 squared, which I won't need my calculator for that. That's just the square root of 2. And now the last triangle I think we can use, and this will help us with CB, is this triangle here. And I might call this point F. So again, drawing this up, so we've got point C, point B, and point F with our right angle. Here we can see the distance between F and C is 2 units. The distance between F and B is 5 plus 2 is 7. So this will be the square root of 7 squared plus 2 squared, which will be 7 squared plus 2 squared, the square root of 53. Alright, so now through those 3 right angled triangles, we've got our 3 sides of our triangle that we rarely care about, triangle ABC. So now we're going to be able to find this angle, and then we'd have all the 3 ingredients required for this area. So I might have to just turn over, and what I might do is redraw this triangle ABC. So and I'll just plot on everything we know. So we've got this triangle here, triangle A, B, C, and we care about this angle. The length of the sides are AC is square root of 2. BC was square root of 53. Sorry, I've drawn this not in a not very helpful way. It's actually at an angle, but hopefully you get the idea. So that's BC, and then AB was the square root of 45. Alright, so now using the cosine rule, we can say that the square root of 53 squared will be equal to the square root of 45 squared plus the square root of 2 squared minus 2 times the square root of 45 times the square root of 2 times cos, I'll just call this theta. So cos theta. So that's the cosine rule. So squaring a square root just gives you what's under the square root sign. So we'll get 53 equals 45 plus 2 minus 2 root 45 root 2 cos theta. So 53 minus 47 is 6, I think. Yep, so we'll get 6 is equal to minus 2 root 45 root 2 cos theta. So cos theta will equal to 6 on negative 2 root 45 root 2. So theta will be the inverse cos of the 6 and 2 will divide. So we'll end up with a negative 3 root 45 root 2. So that's our angle here. So therefore, now we can say the area of triangle ABC is equal to the length of AB times the length of AC times the sine of theta divided by 2. So that there is the formula that we had here. I've just called angle BAC theta. So now we can just plug in our results. So it'll be, I'll just put AB's root 45 times AC root 2 times sine of theta. I'll just leave that as theta before I plug it into my calculator, all divided by 2. So let's see what we get. So first I'll calculate theta. So we'll go, maybe I'll go the square root of 45 times the square root of 2. Invert it because it's 1 over. Then times that by negative 3. Take the inverse cosine of that. And that is theta. So now I want to take the sine of that angle and multiply that by root 45 times root 2, and that's 9. Okay, so that came out as such a clean number. Gives me some confidence I haven't hit anything in my calculator. So 9 on 2. I might just leave it as 9 on 2 units squared. So that's it. That's the area that we were asked to calculate. So in the end, I think for this question, I think the key with a lot of these kind of questions, you plot up the complex numbers in the Argand plane, see what you're dealing with. I think very often you can simplify things by finding the right-angled triangles. In that case, that let us find the lengths of our sides of our unique triangle. And I think whilst we were told just to find AB and AC and the angle BAC, whilst I understand that's what we needed for our area formula, so that's all we were told to find, I think finding the third side then made it quite a straightforward exercise to get the angle. I think maybe that's the part that probably wasn't as obvious to do. You probably could have found this total angle as the sum of these two individual angles, and maybe these individual angles you could have found again using two of the right angled triangles and then added them up. You could probably use the sine rule to work out each of those and you'd probably get to the same place. But I think just finding that extra side and using the cosine rule to me was just the most straightforward way to tackle this. So hopefully after having worked through all that, it makes sense and you're confident now hopefully that this is something you could do yourself. So yeah, hopefully that's helpful and tick boom.